without using mathematical tables or calculator, evaluate, giving the answer in decimal form. Now the condition in this question is without using mathematical tables or calculator, and then you're supposed to leave the answer in decimal form. Now that means in every step of your working, you're supposed to provide evidence that you have not used a calculator or mathematical table. In the event there is no evidence, you've calculated it manually, you're likely to lose the marks. And therefore you need to be very careful in every step of your working. Show that you've not used the calculator or mathematical tables. Now let's go to the numerator. We start with the numerator. Now the easiest way to work out this question is by first converting. You can begin by converting the decimals to fractions, and then you can then return back, or you can convert them back to the decimals. For example, you have 0.13. 0.13, you can write that one as a fraction as 13 divided by 100, then multiply by 0.3 can be written as a fraction as 3 divided by 10, then subtract 0.003, you can write that one as 3 divided by 1000. That is the first thing. You're doing this in order to simplify your workings. Now from there you can see here you have two operations. You have multiplication and you have a subtraction. So according to the law of BODMAS, you begin with multiplication first. So you're going to work out that first. 13 divided by 100 times 3 over 10. And this will give 13 multiplied by 3. So 13 multiplied by 3, this will give 39. So this will be 39. Then 10 times 100 or 100 times 10, that will give 1000. Subtract 3 divided by 1000. Now after that, you can subtract these now. 39 over 1000, subtract 3 over 1000. The LCM of the denominator is 1000. Then this will give 39, subtract 3, and this will simplify to 36 divided by 1000. Now this is the point now where you revert back to decimal. 36 divided by 1000, this is the same as 0.0. You can see 1 2 3, so 1 2 3, so the decimal should be there. So this is 0.036, like that. So now after working out that, the numerator is done. So now you have 0.036 divided by the denominator is 0.09. Now at this stage, now you can remove the decimals by multiplying the numerator by 1000. Why am I multiplying by 1000? I've looked at where we have the largest number of decimal places. The numerator has 3 decimal places. That is why I'm multiplying by 1000. The denominator by 1000. So this simplifies to the numerator 0.036 times 1000. That will give 36. Then divided by 0. These have to indicate these should provide evidence if not using a calculator. So this is 9 times 10, that will give 90. Now you can simplify these. When you look at 36 divided by 90, you can divide each of these by 9. So 36 divided by 9, that will give 4. 90 divided by 9, that will give 10. So this one simplifies to 4 divided by 10. And 4 divided by 10 is simply 0.4. 0.4. So this will give 0.4 as the solution. Simplify the expression 4x squared subtract 9, everything divided by 2x squared plus x minus 6. Now to simplify this one, we're going to divide it into 2. The numerator, first we simplify the numerator, and then the denominator, and then you get the solution. So look at the numerator. The numerator is 4x squared minus 9. 4x squared minus 9. So when you look at this keenly, you notice that this is a difference of two squares. How is it a difference of two squares? Look at 4x squared. That one is one square, and then we have 9, that is another square. 4x squared is a square of 2x, so 2x squared is 4x squared. Then 9 is a square of 3. How do we factorize difference of two squares? Simply recall these. Given a squared minus b squared, to factorize this one can factorize to a plus b into brackets a minus b. This is what is supposed to guide you in this question. So in 4x squared minus 9, you shall have, we've said that 4x squared is a square of 2x, so you have 2x, then plus the square of 9. Look at 9. 9 is a square of 3, so this is a 3, and then we have 2x minus 3. So this one simply will factorize to that. So that is the numerator. So let's go to the denominator. So the denominator is 2x squared plus x subtract 6. So for this one, you notice that this is a quadratic expression, so we can factorize it, and there are several ways of doing it. So I'll use this method where I'll look for two numbers whose product will be, look at the coefficient of x squared, this 2 multiplied by negative 6. So look for two numbers whose product is negative 12, and their sum should be the coefficient of x is 1. So which are these two numbers? The product is negative 12, and then the sum is 1. This is negative 3 and 4. So therefore, I will simply replace that here. So we have 2x squared, then x. I'll write x in terms of 4x and negative 3x. So x is the same as 4x minus 3x. Notice 4x minus 3x is x, then minus 6. So from here, look at these two and look at these two. What is common between 2x squared and 4x? We have 2x is common. So you have, you remain with x plus 2. Then what is common between negative 3x and negative 6? Negative 3 is common. Then you have x plus 2. So this one simplifies to 2x subtract 3, then x plus 2. So again, this is the denominator. Now let's go to the solution. Now the solution, we take the numerator. What we got in the numerator is here. So 2x plus 3 multiplied by 2x minus 3. Then the denominator is here. So 2x minus 3 x plus 2. So when you look at the numerator and the denominator, you find there's something common, and you find 2x minus 3. You can divide these out. So this will divide out 2x minus 3, and therefore you remain with the solution as 2x plus 3 divided by x plus 2. That is how you're supposed to solve that. A straight line L1 whose equation is y is equals to 2 subtract 1 over 3x meets the y-axis at Q. Another straight line L2 is perpendicular to L1 at Q. Find the equation of line 2 in the form y is equals to mx plus c, where m and c are constants. So let's go to the solution. So you have a straight line L1 whose equation is given, and it meets the y-axis at point Q. So let me sketch here the Cartesian plane, just a sketch. We have the x-axis and the y-axis. So that is the y-axis. So this particular line, assuming that this is the line, this is just a sketch, and this line meets the y-axis. So this is the x-axis. It meets the y-axis at this point, and this point is Q. The equation is given of that line, which is y is equals to 2 subtract that x. So it is possible to get this point Q. Point Q is going to be obtained using the y-intercept. The y-intercept. So when you get the y-intercept, so y-intercept, that is the point where the line cuts the y-axis, we can get these. And you know that at the y-intercept, x is equals to 0. This is what you're going to use. So if you want to get this point where this line cuts the y-axis, we simply get the y-intercept by simply taking the equation of this line, y is equals to 2 minus that x, and then substituting x with 0. So at y-intercept, x is equals to 0. So therefore, y is equals to 2 subtract a third, and then x substitute that with 0. So you get y is equals to 2. And therefore, this point here is 2. The y-intercept is 2. So since we say that at y-intercept x is equals to 0, so we can get the coordinates of point Q. Remember, the x will be 0. This point is 0. And then the y-intercept is 2. So the coordinates of Q is 0, 2. After doing that, we're given that another line L2 is perpendicular to L1 at Q. So there's another line that is perpendicular. Sketch it like that. That line is L2. This is L1. It is perpendicular to that line at Q. So therefore, when you look at line 2, you can see we have a point. We have a point 0, 2. And what we need to get is simply the gradient. So it is possible to get the gradient of L2 knowing the gradient of L1. The gradient of L1 is here. So the gradient is the coefficient of x. So gradient of line 1, we're going to know that by M1 is equals to negative a third. And you know very well that if you have two lines that are perpendicular to one another, and the first line has gradient M1, and then line 2 has a gradient M2, if you take the product of the gradients of two lines that are perpendicular to one another, that product should be negative 1. And therefore, M1 being negative a third, and M2, we don't know M2, and you have the product is negative 1, so we can get the gradient of line 2 to be 3. So now it is possible to get the equation of that line in the form y is equals to mx plus c. So now this is how you get it. So y is equals to mx plus c. That is the equation of line 2. What do we have? We have the gradient. The gradient is m, which is 3. So what we need to get is c, the y-intercept. And to do that, you simply need to take this point Q, because that is the point on line 2, 0, 2, and you have x is 0 and y is 2. So if you substitute this on here, you have y is equals to 2, substitute, then x is equals to 0, and when you substitute that in this equation, you get c to be 2. And therefore, the equation of this line 2 in the form y is equals to mx plus c will be y is equals to 3x plus 2. So that is how you're supposed to get it. A circle of radius 3 centimeters passes through all the vertices of a regular hexagon. Determine the area of the circle that lies outside the hexagon. So I've sketched the hexagon there and the circle passing through all the vertices, and then I've divided the hexagon into equal triangles. Now this is how we are going to get the area that lies outside the hexagon. I'll simply shade that area so that you can be able to identify it. So this is the area that you're supposed to get. So this is the area that lies outside the hexagon. So that is the area that we need to get. So in order to get this area, we will have to get the area of the circle, and then we subtract the area of the hexagon. By doing so, we remain with the shaded area, which is the area outside the hexagon. So how do we get the area of the circle? Pi r squared. So that is pi r squared, 22/7 times radius squared. So that way, and then you subtract the area of the hexagon. Now look at the hexagon. The hexagon is composed of 1, 2, 3, 4, 5, 6 equal triangles. So in order to get the area of the hexagon, we'll get the area, the sum of the areas of all the 6 triangles will give the area of the hexagon. How do we get these? We already know the radius. All these lengths are equal, 3 centimeters. This is the center. And we can be able to get the angle of this angle that is here. So this angle, we simply get it by 360 degrees. That is the angles at a point. And then we divide by, because all of them are equal, we divide by 6. So each of these angles will be 60 degrees. So this is 60 degrees, this is 60 degrees, this is 60 degrees, 60 degrees, 60 degrees, and even this one is 60 degrees. Now, having each of these triangles having the radius 3, and then there is an angle, we can use this formula to get the areas of each of these triangles. I have AB sine theta. You know these. I have AB sine theta, where we have AB is the length of the radius, that is 3 and 3 centimeters, the two sides of a triangle, 3 times 3, and then an included angle which is 60, so sine 60. So that is the area of one triangle, and because there are 6, we multiply by 6, like that. So this is what you're supposed to get in order to obtain the area outside the hexagon. So working out this with your calculator, you get this one is this will give 20. This give 28.29. This one is rounded correct to 4 significant figures, and then a half times 3 times 3 times sine 60 times 6. This will give 23.38. So when you subtract these, you'll get 4.91 centimeters squared. So for x in the equation, 25 raised to power x is equals to 125 raised to power 2/3 divided by 5 raised to power -1. Now the first thing you're going to do, look at the left hand side where we have 25 raised to power x. We can express that using the base 5. Remember 25 is 5 squared written to the base of 5 in index form. Therefore, that will be 5 squared, that is 25, and then there is that power x. So you insert it there. So 25 raised to power x simplifies to 5 raised to power 2x. That is written to the base of 5 in index form. Then we have 125, that one to the base of 5, that one will be 5 cubed. So that one will be 5 cubed, like that. So 125 will be 5 cubed, and then don't forget we have that one raised to power 2/3, then divided by 5 raised to power -1. Now you can see that every term now is expressed to the base of 5. Let us simplify further. So this one will give 5 raised to power 2x is equals to, so when you open these 5 cubed, so this will be 5, let me write it here. So this will be 5 cubed, and then multiply by 2/3. and this one will simplify to 5 squared. So this will be 5 squared like that, then divided by 5 raised power -1. Now interest is the right hand side. Look at the right hand side. So we can simplify this one further. The law of division of indices, when you have the same base, we subtract the powers. So this one can be written as 5 raised power 2x is equals to 5, and then we simply subtract the powers using the law of division of indices. So 2 subtract -1. You need to be very careful there. 2 subtract -1. So this one will simplify to 5 raised power 2x is equals to 5. This will be 5. Then 2 subtract -1 will be 3. Now at this stage, now you can see the right hand side and the left hand side. The base is the same. So at this stage, you simply pick the powers. So you shall have 2x is equals to 3. And this one, solving for x, you divide both sides by 2. You'll have x is equals to 3/2. And you can simplify this one further. And in simplest form, you write it in makes as can leave it as a decimal, 1.5 or 1.5. That is the value of x. A carpenter had 2 big pieces of wood of equal length. The carpenter cut the first piece into smaller pieces of length 15 centimeters each without a remainder. The carpenter cut the second piece into smaller pieces of length 24 centimeters each without a remainder. Determine the minimum length of each of the big pieces of wood. Now, to get the minimum length of each of the big pieces of wood, that one you're going to get it by getting the LCM of the first piece, that is 15 centimeters, and the second piece, which is 24 centimeters. So you simply get the least common multiple of 15 and 24. Now you can use any suitable way of getting the least common multiple of 15 and 24. I will use the prime factorization method. So start by expressing 15 in terms of its prime factors. So this is 3 times 5. And then for 24, express that one in terms of the product of its prime factors. That will be 2 cubed times 3. So after doing that, to get the least common multiple of 15 and 24, you simply pick the highest prime factor in all these prime factors that you have expressed here. So the highest. Now we start with 3, which is the highest prime factor of 3. It is 3 raised to power 1. So you just look at these, pick the highest. The highest is 3. And then we look at 5. So the highest prime factor of 5 is only this one, 5 raised to power 1. And then the highest prime factor of 2 is 2 cubed. So this is what is going to give us the LCM. So therefore, the LCM of 15 and 24 is equals to 3 times 5 times 2 cubed. That will give 120 centimeters. So 120 centimeters is the minimum length of each of the big pieces of wood. A cylindrical container of internal radius 10.5 centimeters has a hemispherical base. The container has water up to a height of 30.5 centimeters. Calculate the surface area of the container that is in contact with the water. Take pi to be 22/7. Now try to bring the picture of a cylinder with a hemispherical base, as you can see there. So I'll use this one to explain. So this container has an internal radius of 10.5. So this one is 10.5. So this one is 10.5 centimeters. And also this one here, this is radius 10.5. And also you should also know that this one is 10.5. So this one is radius and also this one is radius. So then it has water up to a height of 30.5. So 30.5, I can assume that it runs all the way from this point to this point. So 30.5, maybe that is where. So from the bottom here, so we have the whole of this height is 30.5 centimeters. Now, with this information, we need to calculate the surface area of the container that is in contact with the water. We're going to start with the hemispherical base by getting the surface area of the hemisphere that is in contact with the water. So we need to get the surface area of the hemisphere. How do we get the surface area of the hemisphere? So hemisphere, we get the surface area by 2 pi r squared. That is how we get the surface area. So this will be 2 multiplied by 22 divided by 7 times the radius, that is 10.5 squared. So use a calculator to work out this, and this will give 2 times 22 over 7 times 10.5 squared. That will give 693. That will give 693 centimeters squared. Then we go to the other part, now the cylindrical part. The cylindrical part. Now for this one, you need to be very keen. The cylindrical part is this part here. So this is the part that you're going to calculate. So we shall take 30.5. Need to be very careful with that. 30.5, and then subtract the height of the hemispherical part. This is 10.5. I can just complete it so that you can see it here. So this is the part that we need to subtract. So 30.5 subtract 10.5. So the height of the cylinder that is in contact with the water is therefore 20 centimeters. So now let's get the surface area that is in contact with the water for the cylinder. How do we get this? The surface area of that part of the cylinder is going to be given by pi dh or 2 pi RH. You can use either of these. So I will use 2 pi RH. You can use either of these. So 2 times 22 over 7 times the radius, which is 10.5, times the height of the cylinder that is in contact with the water, which is this one here. That is the height, will be 20. So this one will give, when you calculate these, 2 times 22 over 7 times 10.5 times 20, that will give 1320 centimeters squared. Now after getting that, now we have the surface area of the hemisphere that is covered by the water, 693, then the cylindrical part, 1320. So now the total surface area in contact with the water will be given by 683 plus 1320, and this will give 2013 centimeters squared. In the following figure, points A and D are vertices of a trapezium ABCD. Line DC is parallel to line AQ. Line DC is equals to 4 centimeters. Point B lies on the line AQ such that angle DCB is equals to 90 degrees. So the figure is there. Using a ruler and a pair of compasses only, complete the trapezium, hence measure the length of line AB. Now the first thing you're going to do is drawing line DC that is parallel to line AQ. That is where you're going to begin. Drawing line DC, we don't have point C, so we have to locate it after drawing a line from D passing through C that will be parallel to AQ. So that is where we begin. And there are several ways of drawing parallel lines. You can use a set square and a ruler. You can use a pair of compasses and a ruler only as required in this question. So I'll begin by getting the perpendicular distance from D to AQ. That is where I will begin. So standing at D, I will drop perpendicular. So standing at D, drop perpendicular to line AQ. So you just stand at D and then you mark 2 arcs. Mark 2 arcs like that. Then from there, we stand on those arcs that we've made there. Stand on those arcs. So I'll stand on these arcs. First arc is there. And then standing on that arc, you mark another arc there. Then with the same radius, though changing it, you stand at this point here. And then you cut that arc. You cut that arc. Then from there, join this point. So D, join D using straight line, using a ruler. So these will be a perpendicular line, to be a perpendicular line from D to AQ. So it will meet this point here at 90 degrees. So after getting that, I'll use that measurement. So I can name this one to be point N. So look at that height dn. That will be the height of the trapezium. And that is what I'm going to use in order to get a line that is parallel to AQ. So now this is what you're going to do. Now having that distance dn, so stand at D, standard D, and with any suitable radius, I can use any suitable radius. I know there is a distance is given, DC is given as 4, but now I want first to obtain a line that is parallel to that, a line that is parallel to AQ, that is a DC. DC should be parallel to AQ. So draw it like that, and then I stand at N, standing at N with the same radius, I mark an arc there. Then from there, I need to take this height. dn. You know that the distance between any two parallel lines should be constant. So to be very keen with this, so I want to take these. I'm taking that height. I'm taking that height dn. So having height dn, that is height dn, I stand at this arc here, that height, and then you cut that arc. Now you notice that this distance here, this distance is constant. That distance is constant. This distance dn is constant. Now having that, now you can now join D through this point of intersection here. So D through this point, and that line will be parallel to AQ. So let me join that. So from this point, so you join using a straight line and using a ruler. So join it like that. So this line will be parallel. So this line now will be parallel to this, like that. Then now from the statement you given here, DC should be 4 centimeters. Now we can locate C, 4 centimeters. So my pair of compass here is calibrated, so I don't need to use a ruler for that. You can use a ruler in your case. So from D to C, that one should be 4 centimeters. It should be 4 centimeters. it should be 4 centimeters. So let me take, that is 4. That is 4. So let me mark an arc there. That is 4. So therefore C is supposed to be at this point. So this is where we have C. So C is here. So after locating C now, you're given another statement that is going to help us here. That angle DCB is equals to 90. DCB is equals to 90. So therefore we should construct 90 degrees at C. Construct an angle of 90 degrees at C. So using a pair of compass, you stand at C. Stand at C. Then using any suitable radius, you mark an arc there without changing that. You cut on the other side like that. Then now from there, you can now stand on this arc here that you've made and adjust the radius, and then mark bigger arc like that with the same radius. Stand on the other arc that you made there. There it is. And then cut this arc. You cut that arc like that. Then now to obtain that perpendicular distance, just join this point here, point C like that. You join point C using a straight line. So from point C there, you join this point of intersection of these arcs like that. And you notice that this one will be 90 degrees. That will be 90 degrees. So therefore, this point that is here, B will be here. Now B will automatically be located here. This is where we shall have B. So that is B will be there, and you're required to measure the length of line AB. So let me measure the length of AB just using my pair of compass. It is calibrated. So AB, so standing at A. So let me stretch it to where we have so you're supposed to measure AB is there. So mine is 7.8. Mine is 7.8. Can use a ruler to confirm same. Use a ruler to confirm the same. Other one is 7 point. You can see this one is standing at that point. Yeah, it is 7.5.6.7, around 7.7. And see that one is 7.7. Now the reason why you may have yours is will give different measurements. So my length AB is equals to 7.7 centimeters. But in your case, because you're using, you can see I've tried to zoom my page. So the lengths are not the actual ones that you may have on the actual paper, because I've zoomed mine, I've interfered. So my diagram, that is the figure, as you can see it there, it may not be accurate because of zooming and also because of scanning these particular paper. So you can try to do it. The method is the one that is most important. At least you have, if you follow through the method, if I try to zoom it out, you can see the same thing. You're getting 7.7. Yeah, but the diagram is not the accurate one. This one is, remember, this is not the actual paper that I'm using, and that is why you may have this answer being different from the one that you get from the actual marking scheme. The length of a minor arc AB of a circle center O is 10 centimeters. The arc AB subtends an angle of 1.25 radians at O. Calculate the area of the minor sector AOB. Now in this question, you have the angle subtended by this arc given in terms of radians, and then you're given the length of that minor arc. The length of the minor arc is 10 centimeters. Then you're supposed to get the area of the minor arc. Now what you notice in this question, you don't have the radius, because you have, for you to get the area of the minor sector AOB, you need the angle subtended at the center, which we have in form of radians, and you also need to get the radius. So you don't have the radius. So what is going to help us to get the radius is the length of the minor arc. Now how do we get the length of an arc of a circle? The length of an arc of a circle is given by this formula: the angle subtended at the center divided by 360 multiplied by 2 pi r. Now I will convert the radians to degrees. You can proceed with that. There are several ways of solving this question, but I would prefer converting the radians to degrees, and then I work with the degrees. I'll use this formula to convert that 1 radian is equivalent to 57 point, supposed to be 296 degrees. So what about 1.25 radians? So this one you multiply, so you have 1.25 times 57.296, and this one, when you multiply it out, you will get 71.62 degrees, correct, to 4 significant figures. Now that is the angle subtended by the arc AB. Now having these, we can now use it to, given the length of the arc, using this formula now here, the length of the arc, which is 10, is given by, look at this formula, the angle subtended at the center, which is 71.62 degrees, divided by 360, multiplied by 2, multiplied by pi, multiplied by the radius. This is what you're supposed to get, the radius. Now with these now, because you know pi, you can use, you can take pi to be 3.142 or 22/7. So we make r the subject. You're solving for r, you want to get r, so make r the subject. So r will be given by, there's something here I've missed out. So there is pi, well, it is there, you can see. So r will be given by 360 times 10, everything divided by 71.62, multiplied by 2, multiplied by pi. So that is what is going to give you the radius. And I've said pi can be 22/7 because it is not stated. The one you're supposed to use can be 22/7 or 3.142. So once you work out this using a calculator, you get the radius to be exactly 8 centimeters. Now having the radius, now you can get the area of the minor sector because you have now the radius. So how do you get the area of the sector of a circle? Area given by the angle subtended at the center divided by 360 multiplied by pi r squared. So therefore we just need to substitute the angle at the center. We already have that, which is 71.62 degrees divided by 360 multiplied by pi multiplied by the radius squared. The radius is 8. So work out these using a calculator, and these will give 40 centimeters squared. That is the area of the minor sector of the circle. The following figure represents part of a pattern. A line of symmetry L1 of the pattern is also shown, as you can see there. Now, you're supposed to complete the pattern and hence state the order of rotational symmetry of the patterns. Now, what is going to guide you in completing the pattern and hence getting the order of rotational symmetry is that line of symmetry, line 1. A line of symmetry divides any figure into two equal parts. And therefore, when you look at that line, the figure that you see on the right hand side of that line should appear on the left hand side of that line. Everything on the right hand side of L1, that is a line that divides that figure into two equal parts. So whatever we have on the right hand side should also be on the left hand side. That is what you're supposed to do. Now, with that in mind, we should start by drawing these, getting this shape here, this triangle on the other side, exactly in the same shape and also the length. And you're going to do this one accurately. So therefore, we're going to begin by taking this measurement here. We'll start by getting this measurement of this line. So this measurement of that line. So get the measurement of that line, and that with that measurement, kindly make an arc here. Mark an arc there. And then you have this length that is here. You have this length. This length also should also appear here exactly the same way. So that one I'm going to use a ruler to do that. So take a ruler and then I will draw a straight line. Draw a straight line like that. So look at the point of intersection of the arc. The point of intersection of the arc, this is the point and that line. So I need to join this point to this point like that. I need to join it. So this point here, I join it like that. So you can see now I have whatever I have on this side, this shape, I've transferred that shape there because this one is a line of symmetry. Now we need to get this. We need to transfer this one on this side. If you rotate this shape here to this one, there is an angle of rotational symmetry that exists there. And that angle is the one that is going to help us to obtain a similar shape like this one on the opposite side. So looking at these two, if you were to rotate this one so that it can fit exactly onto this one, we need to get a certain angle. This is an angle that we need to obtain. And that angle is the one that is going to help us. There is this angle. If I'm to rotate this one, this will be the angle of rotational symmetry. That will be the angle. So that one, that is the angle. Or you can also measure this other angle here. Also this one can work. So if you want to rotate this one so that it fits exactly onto this shape here, this angle here, this is the angle of rotational symmetry. So let me measure that angle. Let me measure that angle here. Remember, the diagram I'm using is not the actual diagram, so you may find the angle in case we miss on accuracy. You should understand that this one is not the actual paper that I'm using. The diagram might have been distorted because it's not the original paper. So I'm trying to measure that angle here. I think the best one to measure is this one that was there. Let me see. Measure this one. So the angle is here. Can try to measure the other one as well. So as you can see, that angle is 130. The angle is 130 degrees. So look at these. We're measuring from this point. So this angle here, you can see that angle is 130. So from this point to this point, so that angle is 130. So that is what is going to guide us, because if you are to rotate this one so that it can fit exactly onto this, remember this line will come here. So this will be the angle of rotation. So 130 degrees. So on the other side, now this is what you're supposed to do. Now after identifying the angle, now we should try to place it here. So on this side, so place it on this line exactly. We need to be very keen. So want to measure 130. So 130 will be there. Note this point here, 130. So measuring the angle from this line all the way to this point. So that is 130. Then once you've done that, draw a straight line from this point like that, passing through there. So that is there. So this angle here, this is the one that I've measured as 130. This angle is 130. Then I have to measure another angle still, now using this line here, using the other line. Now I'm using this line, the green line. Using that one. So 10, 0, 130. 130 will be here. So 130 will be there. So draw a straight line. That. So the angle that I've measured is this one. So from the green line, so this angle, this one is 130. Then remember the measurement. Remember the measurement that I had taken. The measurement, this length, the length of these remember this length here, this length. So with that length there, mark an arc here, mark an arc there, and also mark an arc here, mark an arc there. That is it. So from there, you join these 2 points, using a straight line. So those 2 points should be joined using a straight line like that. And there you have the complete pattern. As I've said, this one is not the original diagram. That is why you may have a different angle of rotational symmetry, because the figure is not the actual one. The angle might have been distorted because it's not the original paper. But the process of solving it is the one that is very important, ensuring that all these lengths and all the shapes are of the same length. So we've completed. Remember, we said whatever we have on the right hand side should be on the left hand side. So after you've done that, complete the pattern and hence state the order of rotational symmetry. What is the order of rotational symmetry? The order of rotational symmetry means the number of times this figure can fit onto itself without repeating in one complete turn. So if you rotate this one, it will fit onto itself 3 times. So if you are to rotate it, let's say from this point, it will fit onto this, that is one time, then rotate again, it will fit onto this, that is the second time, and then the third time. So this is the first time it will fit onto this if you rotate it, then the second time here, and then the third time it will fit there. So the number of times it fits onto itself in one complete turn, that is the order of rotational symmetry. So it has an order of rotational symmetry, order of 3. Kenyan Bank bought and sold foreign currencies on 2 different days as shown. So we have the dates are there. 1 South African rand, buying and selling, 100 Tanzanian shillings, buying and selling, amount is given there. A South African tourist arrived in Kenya on 12 January 2021 with 15,000 South African rands. He changed the whole amount to Kenyan shillings. While in Kenya, he spent a total of 53,075 and changed the balance to Tanzanian shillings before leaving for Tanzania on 12 February 2021. Determine in Tanzanian shillings the amount he received. Let's proceed to the solution. We start with this date when the tourist arrived with 15,000 South African rand and changed the whole amount to Kenyan shillings. So what will the Kenyan bank do? It will buy. So the Kenyan bank would buy 15,000 South African rands in order to convert that to Kenyan shillings. So we're going to use the buy. So therefore, we shall proceed by writing that 1 South African rand buys at Kenyan shillings 7 and 8 cents. So what about 15,000 South African rands? You say that the Kenyan bank will buy the South African rands in order to give the tourist the Kenyan shillings. So this one we just need to cross multiply, and this is what you're going to get. So you're going to cross multiply like this. So we have 15,000 times 7 and 8 cents, and these will give, you multiply these, you'll get 106,200. That is the amount in Kenyan shilling that tourist will get. Then, while in Kenya, he spent a total of 53,075 and changed the balance to Tanzanian shillings. So let's get the balance. So what remained? So the tourist has 106,200, then spent 53,075. So we subtract together the balance. The balance will be in Kenyan shillings. So this one give, when you subtract these, you get 53,125. So that is the balance. And then this balance, we're given that it was changed to Tanzanian shillings before leaving for Tanzania. So now to convert the balance, that is 53,125, the Kenyan shillings to Tanzanian shillings, the Kenyan bank will sell the Tanzanian shillings to the tourist. It would sell, and therefore we're going to use this rate for sell, that is 100. So we have 100 Tanzanian shillings sells at Kenyan shillings 21 and 25 cents. So what about this balance, which is Kenyan shillings 53,125? So we cross multiply these, and so we shall have 53,125 multiplied by 100, then everything divided by 21.25. So this will give the amount in Tanzanian shillings. Use a calculator to work out these, and this will give 250,000 Tanzanian shillings. So that is how you're supposed to work out these. To summarize these, now one thing that it may help you in solving this kind of question is these acronyms. We have Kcse and we have Fokebu. These acronyms will help you. For example, we have the first one. The first one, Kcse, means KE for Kenyan to foreign. You sell. In case you have the Kenyan currency, you're exchanging it to get the foreign. So you're converting the Kenyan currency to foreign currency. You sell. That is what we've done for this part where we have the Kenyan shillings 53,125 to Tanzanian shillings. Then the second one, Fokebu, this means when you have the foreign money and then you're converting it to Kenyan money, you buy. Very good example is the first instance where we have the foreign money, that is 15,000 South African rands, and you're exchanging that on to get Kenyan shillings. So that is a conversion from foreign to Kenyan. You buy. And that is what we use there. Buy. The coordinates of points O, A, B, and C are 002144 and -17 respectively. The coordinates of point D is XY. Then point M is the midpoint of line CD, and it satisfies the vector equation OM is equals to OA plus 5/2 AB. Determine the coordinates of point D. Now we're going to begin with this statement is very important here. Point M is the midpoint of line CD. Because we already have point C is here, and if we get OM will give us the coordinates of point M, and that will help us to get the point D. So let's begin by getting the coordinates of point M, and we have this vector OA. So vector OA is given by, so you have so this is O, this one is A. So vector OA is given by 2, 1. I'll write it in column form. Then we have AB, vector AB. So vector AB, you get it by getting OB subtract OA. So vector OB, now vector OB is 4, 4. And then we have subtract OA. OA is 2, 1. So this will give 2, 3. So now after getting that, now we can proceed and get OM. So OM is given by OA, which is 2, 1. Then plus 5/2 AB. We got AB as 2, 3, like that. And this will give 2, 1 plus, so 5/2 multiplied by 2, that will give 5. Then 5/2 multiplied by 3, that will give 15 divided by 2, which is 7.5. So when you add these, 2 plus 5, you get 7. Then 1 plus 7.5, you get 8.5. So this is OM. And therefore, the coordinates of point M will be 7, 8.5. So that is what you get. Now, after getting that now, you want to get, you already given that is C, and then you have D. So you given that M is the midpoint, of, so this is M, which is 7, 8.5. Then for D, we don't have D. D is denoted as xy. Then for C, we have C is -1, 7. So now, after getting M, we'll be able to get the coordinates of D. How do you do this? Having the midpoint M of CD. How do we get the midpoint? Remember the midpoint? If I get this one is x1, and then this one is y1, this one is x2, this one is y2. To get the midpoint of CD, you get it like this: x1 plus x2 divided by 2. Then we have y1 plus y2 divided by 2. That is how we get the midpoint. So in this case, you simply need to, x1 will be -1, then plus x2 is x, then you divide by 2, and then y1 is 7, y1 is 7, plus y2 is y, divided by 2. That will give us the midpoint, and the midpoint is 8.5. As simple as that. So from here, we simply need to equate. So these will be equivalent to 7. So -1 plus x divided by 2 is equals to 7. So simply solve this equation. So multiplying both sides by 2, you get -1 plus x is equals to 14. And therefore x will be 15. And then the next one will be, this one is equivalent to this, the y coordinate. And so 7 plus y divided by 2 is equivalent to 8.5. So again, you are solving for y. So 7 plus y is equals to, you multiply both sides by 2. So this will be, this will be 17, like that. It is okay, it is 17. So therefore y will be given by 10. Now we've already obtained x coordinate and the y coordinate. So therefore the coordinates of D will be, the x coordinate is 15, and then the y coordinate is 10. So those are the coordinates of point D. The following figure, not drawn to scale, represents a communication mast. The mast has been divided into 4 equal parts. A point P is 30 meters from the foot of the mast on the same ground level. So the figure is there showing the foot of the mast. Point P is there, and then the 4 marks are given there. The angle of elevation of the third mark from P is 50 degrees. Calculate the height of the mast. So what is going to help us to get the height of the mast? And the height of the mast is this height from the foot of the mast to the 4th mark is this statement that you're given here. The angle of elevation of the third mark from P. The angle of elevation of the third mark from P. So you can try to draw that. So the angle of elevation. So from that mark, let me draw up to that point. So the angle of elevation of the third mark from P, this angle here, is 50 degrees. So with that, you can see we're forming a right angle triangle from P to the third mark and then the foot of the mast. That is forming a right angle triangle, of which you have the angle there and you have one length. So we can use trigonometric ratios to get the height up to the third mark. So from the foot of the mast up to the third mark, we can get that. We can let this height from the foot of the mast to the third mark to be represented by x meters. And therefore, which trig ratio are we going to use to get that? Of course, it is tangent. So tangent of 50 degrees is given by opposite side. Now that is the height from the foot of the mast to the third mark, which is x, divided by adjacent. Adjacent is from P to the foot of the mast, that is 30 meters. So this one will give us x, make x the subject. X will be given by 30 tangent of 50. And this one will give, when you work it out using a calculator, you get 35.75 meters. So that is the height from the foot of the mast to third mark. Now, from the second statement here, we are given that the mast has been divided into 4 equal parts. So, and we have already got the height up to the third mark. So that height that we have obtained is 3/4 of the height of the mast. And therefore, we can let the height of the mast be represented by h. So what we have already obtained is 3/4 of that height. That is from the foot of the mast to the third mark. So we can say 3/4 of the height is 35.75 meters. So what about height? How do we get the height? Just make h the subject of the formula. So h will be 35.75 times 4/3, and this will give 47.67 meters. So that is how you're supposed to get the height of the mast. The following frequency distribution table shows the mass in kilograms of maize flour used by 30 traders. So there is mass in kg, then there is number of traders given there. Calculate the median mass of the maize flour sold. Now, to get the median mass, this one is group data, and this is a formula that you're going to use to get the median. I'll state the formula, and then I'll explain the elements of the formula. So the formula of getting the median is L plus N divided by 2, subtract CF divided by F, everything multiplied by I, where L is the lower class boundary of the median class, and then N is the total frequency, that is the total frequency, and then we have CF is the cumulative frequency above the median class, and then we have F. F is the frequency of the median class, and then I is the class size. So that is the formula. So let us identify this. So we need to have the cumulative frequency column. So cumulative frequency, you get it by taking 3, and the 3 plus 8, you get 11, 11 plus 10, 21, 21 plus 7, you get 28, 28 plus 2, you get 30. So the first step is identifying the median class, and you're going to do this because you're getting the median. We take the total frequency divided by 2, and that is 30. Total frequency is 30 divided by 2. So we will find the median class at the 15th position, So where does that one lie? The 15th position lies here where we have 21. So therefore the median class will be 30 to 39. So 30 to 39. That is why we have 15th or the 15th trader. That is the median class. Now, after getting that, we can now go to the formula. Median is equals to L, the lower class boundary of the median class. The median class is 30 to 39. So the lower class boundary, you take 30, subtract 0.5. So that will be 29.5. Then plus N divided by 2. N is total frequency divided by 2, that is 30 by 2. And then subtract CF. Remember, CF is the cumulative frequency above the median class. So the median class, the cumulative frequency of the median class is 21. The cumulative frequency above that class, 30 to 39, is 11. So subtract 11. Then everything divided by f is the frequency of the median class. The median class is 30 to 39. The frequency of that class is 10. And then everything multiplied by the class size. So for the class size, you can simply use these because all the classes are uniform. You take the upper class boundary, 39.5, subtract the lower class boundary, and this will give 10. So the class size is 10. So that is what you need to calculate to get the median. So we have 29.5 plus this will be 15, subtract 11, divide by 10, multiply by 10. And this one will be 29.5 plus this will be 4 divided by 10, multiply by 10. And you notice that this one will be 29.5 plus 4, which will be 33.5 as the median mass. The table below shows the values of x and some values of y for the curve y is equals to x squared. For the range is given there, x is less than or equal to 3 or greater than or equal to 0. Part A, complete the table by filling in the missing values of y. Start from there. So this one you simply need to use a calculator for this. Y is equals to x squared. So when x is 1.5, you just substitute x with 1.5. So that will be 1.5 squared. And this will give 2.25. So this one will be 2.25. Then again, when x is 2.5, y will be, remember y is equals to x squared. So when x is 2.5, so that will be 2.5 squared. And this one will be 6.25. So that is simply what you need to do. Part B, use the mid-ordinate rule with 3 strips to estimate the area bounded by the curve y is equals to x squared, the x-axis, and the line x is equals to 3. The mid-ordinate rule with 3 strips. So what you need to do is simply dividing these ranges from 0 to 3 and ensure that you have 3 strips. So this is what I will do. So the first strip will begin from 0 all the way to 1. That is the first strip. Then the second strip begins from 1 all the way to 2. You see that? So then the other strip begins from 2 all the way to 3. So you can see you've divided it into 3 strips. So the first strip from 0 to 1, the second strip from 1 to 2, then the other strip, the third strip from 2 to 3. Now, using the mid-ordinate rule, you get the midpoint of each of these strips. So let me create a table here, x, y. So the first strip from 0 to 1, pick the midpoint of that strip, that is the mid-ordinate rule. So the midpoint will be 0.5, that is what you pick. So when x is equals to 0.5, y is equals to 0.25. Then the second strip begins from 1 to 2. So the midpoint of that strip is 1.5. So when x is 1.5, y is 2.25. Then the third strip begins from 2 to 3. Pick the midpoint of that strip. So 2.5, and then the y value will be 6.25. So this is now what you're supposed to use using the mid-ordinate rule. Now, the mid-ordinate rule states that to get the area approximation is done by height multiplied by the sum of the ordinates. Now, when you look at whatever we have here, we need to get the height. H represents the height of the strip. Remember, the strip is from 0 to 1, then 1 to 2, 2 to 3. So the height of each of these strips is 1. So height is 1. You need to understand that. The strips are 3. So from 0 to 1, from 1 to 2, 2 to 3. So you can see that range. 0 to 1, 1 to 2, 2 to 3, that is 1. So height is 1. So area is equals to 1. Then the sum of the ordinates, you're using the ordinates are here. So these are the ordinates that you're going to use. These are the heights. So 0.25 plus 2.25 plus 6.25. So you simply need to add these, and when you add it, you will simply get, just use a calculator for these, 0.25 plus 2.25 plus 6.25. These will give 8.75 square units. That is the area using the mid-ordinate rule. Use the Cartesian plane provided to solve graphically the simultaneous equations 2x plus 3y is equals to 1.2 and 5x plus 4y is equals to 1. To solve these simultaneous equations simultaneously using the graphical method, you're going to take the first equation, draw a straight line, then go to the second equation, draw a straight line, then the point of intersection of the two lines will give us the solution. So let's go straight to the first equation. The first equation is here. So using this equation, you draw a straight line. To draw a straight line using that equation, you need at least 2 points. So I'll choose any 2 suitable points using, because considering the graph, look at the values that are given so that you don't have very big values that will not fit there. So I'll choose 2 points. When x is 0, substitute x 0 in that equation. 2x plus 3y is equals to 1.2 and y will be 0.4. Then again choose another one. When y is 0, substitute 0 in that equation where you have y, substitute that one is 0, you get this one will be 0.6. So those are the 2 points that you're going to use. You go to the second equation, that is 5x plus 4y is equals to 1. So choose 2 points for that again. So let me choose when x is 0. When x is 0, y will be 1 over 4, which is 0.25. And then when y is 0, x will be 1 over 5, which is 0.2. You simply substituting these values in that equation. So after getting now those points, let's go to the first line. 2x plus 3y is equals to 1.2. We plot those values. So the first one is 0, x is 0, 0.4. 0, 0.4. 0, 0.4 will be there. So 0, 0.4, that will be the point. Then 0.60, 0.60 will be here. So 0.60 will be there. So draw a straight line. Draw a straight line. You draw a straight line. And that is the line passing through the 2 points. So these are the 2 points. This one and this one. Those are the 2 points that I used here. We go to the second one. The second one is x is 0, 0, 0.25. So 0, 0.25. So 0.25 is located between, exactly between 0.2 and 0.3. That is where we shall have 0.25. So 0.25 will be located around there. So it will be here. So 0.25 will be there. Then 0.20. 0.20 will be there. So 0.20 will be there. So now draw straight line. Straight line. Straight line passing through those 2 points. So those are the lines. So the first line here, the first line is 2x plus 3y is equals to, so these are 2x plus 3y is equals to 1.2. And then the other one is 5x plus 4y. 5x plus 4y is equals to 1. Now look at the point of intersection of those 2 lines. This is the point of intersection. So let me read the point of intersection. The point of intersection is here. This is the point. So that is the point. So I will try to, so that is the point. So let me drop straight down, and then so that I can read the y value and the x value. Like that. So this is the point. So I want to read let me read the coordinates of this point. So the x value is given here. The x value, we are going to read it here. So what is the size of one small square? 1 centimeter here represents 0.1. So 0.1. So one small square will be, we divide that by 5, and this one will give 0.02. So one small square is 0.02. And therefore, this is a 1, 2. So this is a 0.2. Then there are how many squares? 1, 2. So 0.04. And then this one is almost 0. It is not yet at 0.06. And so we can add 0.0. Is it 2? 1. Can add at least 1 there. So this will give 0.25. Because as you can see, it is not yet at 0.26. So this is 0.22, 0.24, then 0. It is somewhere there. So we are doing some estimation. So 0.25. Then the y coordinate. You read this y coordinate. So we have how many squares? 0.5. So 0. So we add 0.5. You add 0. So how many squares are here? 1, 2. This is 1, 2, 3. So those are 0.06, because one small square is 0.02. So there are 3. So that will be 0.06. And then we can add 1. So 0.01. The other one is just estimating because it is not exactly at 0.08. So 0.2, 0.4, 0.6 exactly. It is okay. So this will give 0.57. So now we have the x coordinate of the point of intersection, which is 0.25. Then the y coordinate is 0.57. And therefore we have solved the equation, the coordinates. If we have to give the coordinate of this point of intersection to be 0.25, 0.57. So the x value is given there, the y value is given there. So that is how you're supposed to solve that.